Antiderivative. A function f(x) is called an antiderivative of f(x) if f prime x equal to fx for all x in the interval. Example: f(x) equal to 1 over 3 x cubed is an antiderivative of fx equal to x squared, because for each x in this interval, f prime x equal to dx 1 over 3 x cubed, and we will get x squared. X squared equal to fx. However, fx equal to 1 over 3 x squared x cubed is not the only antiderivative of f on this interval. If we add any constant c to 1 over 3 x cubed, then the function gx equal to 1 over 3 x cubed plus c is also an antiderivative of f, since g prime x equal to dx 1 over 3 x cubed plus c, and then we get x squared plus 0. Because it is constant, so all constant will always become 0, and we will get fx equal to x squared. The collection of all antiderivative of f is called the indefinite integral of f with respect to x, and is denoted by the integral sign. This symbol is stand for integral sign, f is stand for the integrand of the integral, and x is stand for the variable. The process of finding antiderivative is called antidifferentiation or integration. Thus, if d over dx fx equal to f of x, then integrating the function fx produce an antiderivative of the form fx plus c. To emphasize this process, equation 1 is recast using integral notation, which is integral of fx dx equal to f of x plus c. Where c is understood to represent an arbitrary constant. It is important to note that equation 1 and 2 are just different notation to express the same fact. For example, the integral of x square dx equal to 1 over 3 x cubed plus c is equivalent to d dx 1 over 3 x cubed, which is equal to x squared. Note that if we differentiate an antiderivative of fx, we obtain fx back again. Thus, d over dx fx dx equal to fx. The expression of the integral of fx dx is called an indefinite integral. Alright, here is some example to find the antiderivative. So we have integral of 4x cubed plus 8x squared minus 9 dx. Then we integrate 4x cubed, we got 4x to the power of 4 over 4 plus 8x to the power of 3 over 3 minus 9x plus constant, and then 4x to the power of 4 minus 4, we got 4x to the power of 4 plus 8 over 3 x cubed minus 9x plus constant. So this is the answer. Okay, next, what about the square root function? Let's try. Integral of the square root of x. This function is just the same as integral of x 1 to the power 1 over 2 dx. So this gonna be x to the power of 3 over 2 over 3 plus c. Then we got 3 over 2 square root of x cubed plus c. So this is the answer. Okay, next, what is the antiderivative of the integral of 3x minus 1 to the power of 2 dx? Okay, then got 3x minus 1, 3x minus 1. So, okay, 3x times 3x, we get 9x. 3x times negative 1, we get negative 3x. Negative 1 times 3x, get negative 3x. Negative 1 times negative 1, get positive 1. We solve it, then we got 9x negative 3x minus negative 3x, we get negative 6x. To get the square root, and then plus 1. X. Then we integrate it. 9x to the power of 3 over 3 minus 6x to the power of 2 over 2 plus 1x. And when we can plus constant, then we simplify it. We got 3x cubed minus 3x squared plus x plus constant. So this is the answer.
Now I will explain about integration formula. Every time you integrate a function, as example, function 1 dx, it will be equal to x plus c. You must add a constant. This c is a constant value. And next, a new type of problem is when you integrate a function that have x to the power of n. Dx is equal to x to the power of n plus 1 divided by n plus 1 plus c as a constant. So, in normal example of normal question, the x usually given in integral like 3 dx. So how we do it? The power we must add 1 resulting to x power of 4 n plus 1 also 4 plus c. The integration of unknown x power of 4 dx equal to, as we learned before, we must add the power with 1, and the result is x 5 divided by 5 plus the constant of c. Okay, so this is the next type of problem when we're dealing with the fraction. As example, when we're dealing with unknown x, 1 over 2 dx. How do we solve it? Same as previously, we add with 1. A half add by 1 equal to 3 over 2. We can write our answer like this. For example, x to the power of 3 over 2 divided by 3 over 2 close bracket plus c equal to x to the power of 3 plus 3 over 2, when we change the operation, it will become times 2 over 3 plus a constant c. And we can also write it as 2x the power of 3 over 2 divided by 3 plus c constant. I'm sorry. 2x 3 over 2 divided by 3 plus c constant. How about integration of square root x? How we solve this type of problem? Until now, we have dealing with power of n as integral and fraction. How about this square root? Okay, this square root, we can also write it as x to the power of 1 over 2. As I explained previously, we can solve this by converting the square root into this, and we can do exactly as previously, integrate as previously to get 1 over 2, add with 1 become 3 over 2 divided by 3 over 2 plus with constant, and then we get as an answer is previously, the exact answer as previously, 2x 3 over 2 minus divided by 3 plus the constant c. We can also write as 2 the square root of x to the square root of x to the power of 3 divided by 3 plus c.
So, properties of indefinite integral. So there are 3 theorems for these properties. Theorem number 1 show that if a constant time with a function what can we do with that c? We can take out c and then we integrate the function of x. This is theorem number 1. Theorem number 2 if two functions are being added, we can separate them. That's mean integrate function f plus with integrate gx dx. Properties number 3 show that if two functions, if one function minus another function we also can separate them into two functions. So this is three properties, three theorem for properties of indefinite integral. So in general, to establish the validity of an equation of the form, we must show that hx dx is equal to, when we integrate, it will become hx plus c. Same also when we differentiate the hx, it will become hx. So we are given that fx and gx are antiderivative of fx and gx. So we know that when we differentiate fx, it will become fx. When we differentiate gx, it will become gx. Thus, when we differentiate a constant function x, the constant we put at the in front, and then we differentiate the function of x, and then it will become c fx. So the theorem number 1 is proof. This is correct. For the theorem number 2, when we differentiate fx plus with gx, we also can differentiate them by separating them. Function x plus differentiate gx equal to fx plus gx. So this is proof for theorem number 2. So for the theorem number 3, in differentiate also, when we have two functions are being substituted, we also can differentiate them by separating them into two. then fx minus gx. So this is the proof for the all three statement of the theorem. So the three theorem can be summarized as C times function x dx. We bring out C, then integrate the function of x. Gx we can summarize as function of x dx plus gx dx. So for the theorem number 3, we summarize as fx plus minus gx dx into integrate fx dx minus gx dx.
Remember that if you are integrating the indefinite integral in the last result, you need to do a plus c at the behind so that it plus a constant number. The first example of question for the power rule is I choose from the exercise set 5.2 question 9a, which integrate x to the power of 8 dx. So this is a straightforward question which we integrate x and the power 8 plus 1 divided by 8 plus 1. Hence, when we simplify, we get x to the power of 9 over 9 plus c. The second example question for the power rule is from question 9b. They ask us to integrate x to the power of 5 over 7 dx. Same step as before, which we integrate x power plus 1, which will be 5 over 7 plus 1 divided by 5 plus 7 plus 1. Lastly, when we simplify, we get 7 over 12 x to the power of 12 over 7 plus c. Example for the sum rule from the question 11 and question 15 from the exercise set 5.2. Question 11 us to integrate 5x plus 2 over 3x to the power of 5 dx. To make things easier to be seen, what we should do is to split out this term into two different terms, which will be the integrate 5x dx plus 2 over 3 x to the power of 5 dx. Basically, what I wrote, I already applied the constant coefficient rule, which I take out the constant number to the front. Next, the constant 5 times x to the power of 1 plus 1 over 1 plus 1 plus constant 2 over 3 times x to the power of negative 5 plus 1 divided by negative 5 plus 1. Lastly, what I did is I simplify the previous step into 5 over 2 x to the power of 2 minus 1 over 6 x to the power of 4, and not to forget the plus c at the behind. Thus, the answer will be like this. The next example of question for the sum rule is from question 15 exercise set 5.2. The question asks us to integrate x, open bracket 1 plus x to the power of 3 close bracket dx. To make it easier, we expand the function x times 1 will be x, and x times x to the power of 3 will be x to the power of 4, which will be the integration of x plus x to the power of 4 dx. Next, I split it into two terms, which will be integrate x dx plus integrate x to the power of 4 dx. Using the same basic rule of integration, we integrate x, which will be n plus 1 over n plus 1, plus integrate x to the power of 4, which will be x 4 plus 1 over 4 plus 1. Thus, the end result is x power of 2 over 2 plus x power of 5 over 5, and don't forget plus c. The next example of question is for the difference rule from exercise 5.2, question 20. Question asks to integrate 1 minus 2t power of 3 divided by t power of 3 dt. For this kind of question, to make it easier, we just divide the numerator with the denominator, which is t power of 3. So it will be integrate 1 over t power of 3 minus 2 dt. Thus, we get the easier version to integrate the question. Next, integrate 1 by 1 like usual. There will be t power of negative 3 plus 1 divided by negative 3 plus 1 minus the integration of 2, that would be 2t. Lastly, we will get negative 1 over 2t squared minus 2t.